नशे से चढ़ गई कुड़ी नशे से चढ़ गई पतंग से लड़ गई कुड़ी पतंग से लड़ गई ऐसे खेचे दिल के पेच।
Okay, in this video we're going to pick up where we left off last time, and we're going to add on some leverage now. So we're going to look at the effect of leverage, and the main takeaway is going to be that there is going to be increased variability, increased volatility. So we're going to consider the same asset that we talked about last time, but now we're going to layer on a loan of $700,000 at an interest rate of 7% per year. The loan payments are going to be based on the annual payments with the loan balance amortized over 20 years. So the cash flows from the property are going to still be uncertain, but now we're sticking on fixed payments of about $66,000 per year. In this case, there's going to be positive leverage. We'll talk a little bit about that later. The interest rate basically is 7%. The unlevered return, the expected return was about 13.2 as I recall. So that means we're going to have positive leverage. And actually all of the scenarios even had above 7%. So we're going to have positive leverage in every scenario. But we're going to see a bigger spread in the possible outcomes, and there's going to be more uncertainty. Now we're going to see the expected return is going to jump up to about 25%. The standard deviation is going to be around 13.6. And then I'm going to show you a data table and a graph that shows the effect of the higher leverage on the standard deviation of returns. So this is kind of setting the groundwork. Let's go to the spreadsheet and look at all of these details. So here's the spreadsheet, and we've now layered on the loan, and that's what's going on in the bottom half of this sheet. We've got a 70% loan to value, 7% interest rate, and a 20-year term that we're amortizing. So I'm going to show you the annual payments. We've got all of those pieces, and we assumed annual payments. This is a little bit kind of weird. Normally we would get monthly payments and then annualize them, but just for simplicity, I treated this as 20 periods with a 7% annual periodic rate. And so we come up with this annual payment of $66,000. And a loan payoff, once we sell the property, of course, we have to pay off our loan. There's going to be the future value function is what we're going to be using. And we see that we're going to pay down this loan to a principal balance of around $600,000, a little over that. So here's what we're concerned with is what our leveraged cash flows look like. And actually, I want to have both pieces here. Our leverage cash flow for time period 1 is going to be what we had before, the $1 million, but now we're going to get a loan of 70%. And so our out of pocket cash will be $300,000 in all of these scenarios. Let's look at year 1, and we'll take, for instance, the pessimistic scenario. That's going to be linking up above to the pessimistic scenario unlevered. That's $100,000 in year 1. And then we're going to subtract out the annual payment that's going to be constant across all of our scenarios now with the leverage. So this bottom half of the spreadsheet, every year we're going to be paying that $66,000. So that's what's happening with year 1 in the pessimistic scenario. My $100,000 is reduced by the $66,075, and so I net up with $33,925. That's what I end up with in the pessimistic scenario, year 1, after we've added on leverage. And so for all of the years for the pessimistic scenario, my cash flows look like this. Year 5 is a special one because we not only get that $992,000, which includes our operations and our selling, but we have to pay out the annual loan payment, the debt service, and we have to pay off the loan. So we're netting this $324,000 after the end of the 5th year. Same thing for the other 2 scenarios, the most likely scenario and the optimistic scenario. If we just pick a year here, you can see what's happening. We're looking at year 3's optimistic cash flow up above, $126,000. We net out the annual debt service payment of $66,000, and so we walk away with $59,925 in year 2. Did I say year 3 or year 2? I'm not sure. Anyway, year 2, that's the cash flow that we would have after leverage is included. And again, we get the weighted average down here. We're going to use those probabilities for each of these years. We have just the weighted average for those different scenarios, and we come up with the expected return across all 3 scenarios of 24.67%, a little under 25. Again, we calculate standard deviations the exact same way. So my return in the pessimistic scenario is 3%. Ooh, this is not right. This should be down here. So we're going to subtract the return from this expected return. The deviation here is again there. And the deviation here. So we're looking at the difference between what the return is and what it would have been across all scenarios. So the expected return across all scenarios. So this part works fine. Our standard deviation isn't quite as exciting. It was 13.6 before the mistakes, or before the mistakes were corrected, but it's still higher. It's still 8.5, which is higher than the 3.2. So our story didn't change. Now we just have corrected numbers. So again, these are deviations squared. So everything else is fine. And then we're going to multiply that times the probability. So the end result is our standard deviation did go up, and that's going to happen whenever we add on financial leverage. So back to the PowerPoint document here. We got that 25%. The standard deviation is not 13.6, it's 8.5, but still it has gone up. And next I want to look at a data table and a graph that shows the effect of the higher leverage. So let's go back to the spreadsheet, and we're going to move over here to the right. And these things are linked to the numbers in over here to the left. So let me show you what the data table is doing here. This left side is our loan to value. So we go 0 to 95%. And this is the standard deviation across all of those different loan to value. So as we increase the loan to value, we're using more leverage, and we're increasing the standard deviation. So let me show you how this data table is working. This is a new skill, I think, that we haven't talked about, that I'm going to ask you questions on. You're going to create this on your own, so pay attention now. And let's talk about how we're going to do this. So let me get rid of, I think I'm going to have to get rid of this whole thing, but let me just try to get rid of this. Okay. So here's how a data table works. We want to have the thing that we're concerned with. In this case, we want to see what the effect of changing the loan to value is. So we're concerned with how the risk is changing based on how much loan we're getting. So I've picked a variety of numbers here. I'll either provide those to you or have you come up with them. But yeah, in this case, I've just provided these numbers. This is what I want to find out. What is the effect of these different loan to values on the standard deviation or the risk of this asset? And up here in this little cell, and by the way, notice that there is a blank column right now. We need to have that anytime you're setting up a data table. You want to have a blank row, not a blank column, a blank row before you stick all the inputs that you're concerned with. And in this little special cell right here, we're going to link to the standard deviation that we're concerned with. So I'm going to link down to, did I say standard deviation that we're concerned with? It's the cell that we're concerned with. In this case, it is the standard deviation that we want to see. So I'm going to link to that. And you can see that I just got the number there. And now here's how you would create a data table. We're going to highlight these two columns. And we're starting with that blank cell and pulling it all the way down to the right. And then I'm going to go to data up here on the basically, I guess, the middle up in the ribbon. And we're going to go to what if analysis, and we're going to choose data table. Now notice over here we have two possible inputs. There's the row input cell and the column input cell. Our numbers that we're wanting to try out are all in a column, so I'm going to use the column input cell. And those numbers are all loan to values, so I'm going to link to the input cell that is a loan to value, and that is way over here. So notice what's happening. I've got A15 as my column input cell, and I'm linking to the loan to value. When I hit OK, Excel magically fills that table out, which is really cool because it's saying if we had 70% loan to value, our standard deviation is going to be 8.54. We already knew that. But what if we dropped it down to 50? Well, our standard deviation would only be 5.81. What if we went to 95%? Well, our output, our standard deviation would be 26.8%. So this allows you, instead of going in iteratively each time trying a new number, you can just stick all of your numbers in this column and get the output. And then here is a graphical representation down here of that table we have below. And you can see how the risk increases, and it's not a linear relationship. It's definitely kind of an exponential increase in the risk as you add more and more debt. So that is the long and the short of adding leverage. It increases risk, and we're going to stop with this video, and we'll come back and look at the next slide, which is an example of an apartment building, and we're going to see what happens when we stick on leverage. So I'll see you in the next video, and until then, goodbye.
Je suis fou de toi.
नशे से चढ़ गई ओए कुड़ी नशे से चढ़ गई पतंग से लड़ गई ओए कुड़ी पतंग से लड़ गई ऐसे खेचे दिल के